Hello everyone, it's April the 10th. Look at this. Congratulations on 100-day badge in 2024. Awarded to top 4.2% of LeetCoders solving problems 100 plus days in 2024. Well, whatever. That's not what I'm aiming for. I'm aiming for 2,000. So I have 624 days to go, which is 2 years, right? Yeah, 2 years. Review cards in increasing order. Given an integer array deck, there is a deck of cards where every card has a unique integer. The integer on the ith card is deck I. You can order the deck in any order you want. Initially, all the cards start facing down. It will do the following steps repeatedly until all cards are revealed. Take the top card of the deck, reveal it, and take it out of the deck. If there are still cards in the deck, then put the next top card of the deck at the bottom of the deck. If there are still unrevealed cards, go back to step. So basically, if there is, so we start with take the top, right? We take the top, review it, and take it out. If there's more, we'll put it at the back. And next, we'll take it out. Yeah, so in this case, yeah, we can actually go through the order of the deck that will reveal the cards increasing. Return ordering of the deck that would reveal the cards in increasing order. Okay, so we have 17, 13, 11, 2, 3, 5, and 7. So what we do is we'll review the first one, right? So 1, 2, 3, 4, 5, 6, 7. We'll review the first one, move the second one to the back, review this, move this to the back, review this, move this to the back, review this, move this to the back again, review this, move this to the back, review this. We don't move at the end. Review this. Yeah, we can move again, but at the end, I want to move this. Therefore, if we want to do it in an order, so it should be 2. So something will be reviewed at this. Yeah, so we go 2, 3, 5, 7, 11, 13, 17. So it should be this. 13 is here. And then next review is 3. This is here. 17, 13, 11. And then 2, 3, 5. Then this will be the last one, 17. And then 5, 7. Right, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So 2, 3, 2, 13, 3, 11, 5, 17, 7. Okay. Or at least we went through the whole thing, and then we have a general understanding of what it is asking for. Holy crap. Well, we can know. So given the number, we can know these are even positions. 0, 1, 2, 4, 5. 0, 1, 2, 3, 4, 5, 6. Right? These are determined. And if we have even number, then yeah, well, like these positions, this are determined, right? These positions are determined. So now we have the remaining ones, and the remaining ones right, it's 0, 1, 2, 3, 4, 5, 6. It's the even ones gets remained. And when you move it down to the end, this basically becomes 7. Right? This becomes 7. Yeah, this basically becomes 7. And it become 8. And this become 9. Right? And then 7 got skipped. 8 got revealed. Right? 8 got reviewed. Wait, hold a second. What are you doing, man? We want to find this. Nah. Yeah, 1, 2, 3, 4, 5, 6, 7. Right, so this is 0, 1, 2, 3, 4, 5, 6. So we know 0, 2, 5, and 7. Right. Now for the remaining, this will go to the end. So this will become 7. Right, and then this one will become 8. This one will become 9. So 8 will be the next one getting reviewed. So this has to be 11. Right? And then we'll go to the end. Because now I have 3. Right? Basically now we have 3. With 7, 8, 9. Right? So, and 7 does not get revealed. So this has to plus, this become plus 3. Right? So big 10. This one we're done. And this one become 12. So now they're even. So this will become 13. This will become 17. So we put 13 here, we'll put 17 here. So, what was the solution then? Well, the solution is we'll mark all the evens as we go through. Yeah, as we go through, we'll mark all the evens. And then all the odds will get to the next round of evens. Now we go back to do all the odds. It's like a BFS. Right, we handle all the odds. And whoever is even in there will get it, otherwise we'll go. Okay. Okay, I think we have an idea. But the question is, how do we mark it back to the original position? That is a good question. How do we mark it back to the original position? Do we need to use a map for this? All right, can we not just add to the end? I think we can reset the numbers, right? We can reset the numbers. Because all we need to know if it's even or odd. So initially we have 1, 3 and 5, right? 1, 1, 3, 5. And then we go to the end. So we go to the end. Go to the end. Basically, this can be 7, 8, 9. We can actually call it. I call it 1, 2, 3. I guess it doesn't really matter. Yeah, who gets out first? That's the question. Uh. Yeah, how do we map it back? So anyway, we'll sort the deck first. Then we have an index, and then we go if it's even, put it in. If it's odd, we push into something else. Yes, we can push a. Okay, I want to push an array. Okay, I want to do an array. I think that should work. Oh, the sleep is creeping in. I can feel it. I can feel it. It's taking over very soon. Oh. Okay. Okay, we'll sort it. Okay. Then what we're gonna do is, do we make change in the deck itself? I guess I can. Probably not. It's okay, now we have the result. And we're gonna do array list. I'll call it Q. That's okay. Ooh. Oh, we need to put something in first. Oh man. Okay, let's do it while true then. It's okay. Alright, well, push stuff into the. Actually, that's not. Yeah, hold on. We have to push stuff into the queue. Yeah, we just run once, we push it into the queue, and then we go through the queue. That's okay. Right? That's okay. Alright, so for int I is 0I smaller than deck dot length I plus plus. Alright, so we go through each. We say if I model 2 is equal to 0, right? Now I say res I or equal to deck index plus plus. Else q dot add new int. So we're gonna have to push the damn. In j equal to 0. Okay. Nah, j is not equal to 0. J shall equal to deck.length. So we'll push the new one, j, and the old one. Right. And once we push it, j need a plus plus. So we'll go through this, right? Go through this. Then we can say, well, q, right? Q well, it's now empty. We'll pop it out, right? Oh, I think I need to use a deck. Okay, that's not right. Array deck. Oh yeah, it's array deck. Right, that's fine. And you add. At last. Okay. So we say int element equal to q dot pop move first. Right. At a 0 mod 2 z equal to 0. Then we do res ll1 equal to deck index plus plus. Okay. Else, oh, in the new one, so deck. Oh, I could just push it to the back of the deck. Right? I could push it to the back of the deck. Yeah, I can do that. I see. Oh, push everything into the deck first. Oh. So I don't need this. Don't need this. I'll push everybody in. Right, this is just the beginning. I put everybody in. And then what we do, we check. If it's equal to 0, then it's this equal to deck, yes. If it's not, then we say q dot add last new int. So, ooh, the length. Oh, it should be the current size of the queue, right? That's not necessarily true. if it's equal to 0, or actually that's fine, the last one, right? But it says Q is not empty, and I move it, then Q become empty, right? Then Q become empty, or Q dot is empty, right? Then we do this. Otherwise, so Q is not empty after we pop it. Then we add the last. We check whichever is at the last and then +1. Then we say Q dot peak last 0, right, +1 and element 1. Yeah, we'll just keep adding it. Oh, until the end we're done, so we're gonna return rest. Alright, let's see. Yeah, this one, right? Oh, I'm so tired. Okay, this one looks good. So it's like a simulation, right? This is basic simulation. It's not even sure if it's correct, but let's just do it. 950. Simulate the whole deck revealing process. The only modification is that we keep track of the pseudo indices of the numbers of the cards and use them to decide whether a card is ready to be revealed. I don't know, we'll call it O(n squared because you have to push it to the back. Yeah, we can call it O(n squared. I think it is O(n squared. Let's not do that. Just in case it was wrong. Okay. I'm pretty sure it's O(n squared, and then based on this, it's likely that we have a better solution. Yeah, because this is basically just simulation. Two pointers. O(n login. Simulate with Q. Oh, it's O(n login. What? It's so much simpler. What is this? What's deck? Deck is just deck. Put a card as a correct index. Result for card in deck. The deck is sorted. Review card. Push it back to the queue. And then we are looking at the second. Oh, I think this one's putting the indices. Right, putting the indices. So the first indice will get reviewed. And then yeah, what's the indices, right? Man, like past a certain hour, the brain just stops working, man. I try really hard to focus, but I can't. Dude, man. Alright, so sorted. We basically say, okay, where do you put this one? And then I pop the indices out. And then you'll go there. Right, then we go to the next one. Then we pop the next one out. Oh, I think I know. I know. Simulation is actually not that bad. But my way of simulating definitely is not right. Simulated approach on the official solution. We'll sort it. We don't need this. We do need result. We need a deck, but we don't need this. It needs to be integer. Indices. Okay. Then we just say for int d, because we want to know where each integer will go. So for each d, I check the indices. Yeah, so you put at the, so you do this and you put at the end, right? So indices, and then we say for int I 0 smaller than deck, the length plus indices, add last. Okay. Then we go through the deck for each one. We say result. Indices. I don't have the peak. We can just remove first. Right. That shall equal to d is a remove first. Then we say if indices that is not right. If it's not empty, then indices dot add last, indices dot remove first. Now we go through every single one, and then we can just return. All right, let's try this one. Yeah. Yeah, that's the right way. Okay. That's it. All right, I'll see you guys tomorrow. Adios.